Welcome, my friends, to the very first video of the IB Physics Topic 1. And as you can see, we're going to go through a whole bunch of stuff related to magnitudes, units, conversions of units, and none of this stuff is rocket science, so we're going to go pretty fast. That's why there's so much stuff. In the crazy world of science, you often deal with giant numbers and tiny numbers, often expressed as magnitudes of 10, positive or negative magnitudes. And the IB wants you to know a few key limits on some big things and small things. Take a minute, pause it, see if you can see which of these exponents goes into which box. Boom, there are the answers. Take a minute, write these down, do whatever you need to remember them. I have actually seen the IB on tests, test kids on these actual values, which I think is absolutely stupid, but it happens. Write them down. Now take a minute, read this question, and know that when it's asking for how many magnitudes of order larger something is, that's asking for a ratio. So pause it, see if you can figure out this ratio problem. Now, hopefully, what you had was something like your 2,500 kilograms divided by your, you gotta put them in the same units. Same thing for the squirrel. Turn into scientific notation. Then you can round and say that this is pretty much the same as 1. So this is just 10 to the third. This 8.5 is like a 10, or close to it. Then you put these together, and you've got 10 to the third divided by 10 to the negative first, and that's going to be pretty much like 10 to the fourth. So then our answer is that the T-Rex is 4 magnitudes larger than the squirrel. Now, estimating the magnitude is important when you got to make some kind of wild guesses, even about things you don't really know much about. For example, if I want to know to, let's say, 1 sig fig, the magnitude of people that can fit in an NBA basketball arena, I just ask myself, can I fit 100, 1,000, certainly more than that? Can I fit 10,000? Or can I fit 100,000? And I think 100,000 is way too big, so 10,000 is more likely. So the magnitude is going to be 10 to the fourth. I just got to get close. So pause it, see if you can figure out to the right magnitude the numbers for these here. Now for an elephant, it's a question of, does an elephant weigh 1,000 kilograms, closer to, or closer to 10,000 kilograms? I think it falls in between, but I'm going to go with this. So I'm going to say it's probably 10 to the third. Earth, I think the Earth is probably somewhere between 1,000 and 10,000 kilometers across. I think it's closer to 10,000, so that's going to be 10 to the third, sorry, 10 to the fourth, plus, or times 10 to the third, because I'm going from kilometers to meters. So that's going to be 10 to the seventh. In meters. Commercial jet, I don't know, 100 meters per second or 10 meters per second is too small. 100 meters per second, maybe 1,000 meters per second. That's faster than the speed of sound, because I know sound is 300 some meters per second. So I'm going to go with this. So I'm going to say that that is 10 to the second. And these are my magnitudes. You have to know what the fundamental units are, and keep in mind that these are not the same thing as derived units. An example of a derived unit would be something like a watt, because a watt is a unit of power or a rate of energy use, which can break down into a joule second. And then a joule can also is a derived unit, and that can break down into a Newton meter. And then a Newton can break down. But the fundamental units that all derived units can be broken down into, if you want, are these 6 here. And they can, you can use the acronym to remember them with KKAS, mole M, pretend that's an M. And the mnemonic that you can use to remember them is that killer kangaroos are surely murderous marsupials. And then you can remember kilogram, Kelvin, amp, second, mole, meter. Everyone around the world knows that common phrase that I just made up. When you're converting between different units, I don't really care what method you use to do so, as long as it consistently works for you. Let's say we're going to convert the speed of sound, which most people know in meters per second, into kilometers per hour. What I'm going to do is I'm going to write it like this. And first I'm going to get my meters into kilometers. And so I know that a kilometer is 1,000, 10 to the third meters. And I cancel my units when they go away. And I want to get seconds into hours. So I know that 1 hour is going to be 3,600 seconds. Seconds go away. Then I multiply everything across the top, divide by everything on bottom, and this is going to spit out 24 kilometers per hour. And then I was in 2 sig figs here, so I'm going to round this to 2 sig figs. I'm going to get about 1,200 kilometers per hour, which I should write this as kilometers per hour to the -1. Although, I think that's kind of a silly way to write it. That's what the IB wants. And the IB's way of writing units, even though I think it's kind of dumb, is that you are not supposed to put that in fractional form. Meters per second becomes meters second to the -1. Revs per minute, same way. Revs minutes to the -1. Acceleration would become ms to the -2. The end. Woo!